Hello everybody, thank you Fatima for the invitation, and I have the best slot in the world, the digestion time slot, when everybody is digesting their food. So I will try to be quick and to entertain you regarding the paper recycling and paper-based packaging trends and challenges. So, when we talk about paper industry, we like to peddle ourselves that we are good guys, that we are overachieving the targets the European Union has set, so why should we bother? We are the good guys, plastic is bad. Because the new EU Packaging Waste Directive defined the future checkpoints, and you can see the numbers. For paper, currently they said 60%, for 2025, 75%, and for 2030, 85%. So, question, what is the current rate in 2021? This is a trick question because I already gave the answer. So in 2021, the paper industry recycled 71.4 of all paper and board consumed in Europe. So, just a little bit more and we will be achieving 225 with no problems. Or is it so? Let's see. So, I will start with the classic ones that you already know from the school, kindergarten, why we have to recycle paper. Because it's good for nature. With recycling 1 ton of paper, we reduce the consumption of 70 log trees, 26 liters of water, 2.3 cubic meters of landfill, 320 liters of oil, and 4,100 kilowatts of electric energy, which is a supply of a 3-room flat in European Union. So for every ton, we can heat 1 basement anywhere in Europe. Okay, the second one, bless you. Why it's good that we recycle substrates? Because if we take down the CO2 of a classical packaging, the paper is more than half of it. So it's basically 60% of CO2 for a paper-based packaging goes to paper production. Others are inks, production of the purchased energy, on-site combustion, and so on. So basically paper is the most greedy material regarding CO2 in a paper-based packaging. The other thing that nobody is talking about, and I always try to make people wonder, there will be not enough cellulose. You said, this guy is crazy. He's come from the third most forested country in Europe, Slovenia. And I'm saying that there will be not enough cellulose. Why? Because all the brands are rushing to paper. To cellulose packaging, it is the holy material, it is renewable, we can have it all from paper, but the problem is that we have a stalling recycling rate, and the biomass strategy for incineration is in collision with the consumption of paper. So basically, yes, we can cut out all the forests, we can make paper packaging, we can make biomass energy, waste to energy consumption, but again, then we will have no forests and no biomass. And current plans, which the EU is pushing, is 40 to 100% of more biomass is needed than it's likely to be available. And nobody's talking about this. That is one of the problems. The second problem is, and some companies know this, because we are doing a lot of research regarding alternatives, which are non-woody species. They are surfacing seagrass, they are surfacing different alternative plants, biomass, because woody bioplants are in danger, and also you have to have the CO2 sequestration. You have a CO2 in the forest, then you cut it out and your CO2 goes up. So it's like a balance. You have to have it very, very carefully balanced. And the problem is that a lot of people are using biomass for energy production. In Slovenia, when the gas went up, everybody went for wood, biomass. So basically, it's a very complex problem, but this rush of the brands to the paper is making things worse. So, what's happening on the dashboard if we see the paper recycling and paper consumption? We can see that the paper consumption has a quite steady line, and also the paper recycling has a quite steady line. And this is the newest data of the paper for recycling in CEPI countries, so it's basically European countries, which is also stagnating. And basically, these numbers are okay, but where is the next step? How we will achieve that 75? And here comes the problem, because we have a systemic challenge how to achieve 75. The problem of the last percentile or mile is that basically we have three sources where paper comes for recycling. So we have the industrial, the commercial, and we have the sorted household. And if we take a look at the numbers, the industrial and commercial 85, 84, overachieving. But the main problem lies at us, at our homes, 55%. So if you know a little bit arithmetics, that we gain 75, we have to push this number quite a lot. No? In 2 years. Can we achieve it? What do you think? Yes or no? No, because the recycling rate is low. I see in Slovenia, I see in every country, people are mixing at the household, even I sometimes mix wrong paper with some lightweight boards. So basically we have a problem at our houses. And that's why some industries are, like the paper industry wants to change this. And basically the mixed material originating from households and commercial activities is around 66, but our household is just 55. So we have to change our collecting systems that we can achieve this. The another problem, like I said, is the change in structure. So total board and paper, everybody thinks that, yeah, paper is rising. No, it's stagnating, but the internal structure of the paper production is different. You have packaging, which is on the rise, and you have graphic papers, which are falling down. So newspapers, magazines are falling down. And what does it mean? Newspapers and magazines have the nice white fibers. These are the ugly brown fibers. So basically, you have a big structural change that you want good white fibers, you cannot get them. You have to use raw materials, and you get different kind of quality of the fibers because the structure in the paper industry is changing. So basically, this has to do with the recycling ratio falling down. Like you saw, it's stagnating and a little bit falling down. Why? Because we use more and more mixed paper sources with different kind of coatings, different kind of plastic packaging, and we mix it at home from fast food systems, from everything, and we are decreasing the recycling of the paper. When people collect the paper at, I don't know, shop, it's a 100% almost pure paper source. But at home, we make a mess. And we make a mess at home, then we decrease the recycling ratio of the papers. So this paper sorting starts to be a systemic challenge and for improved recyclability. And this sorting of the mixed waste streams, like packaging waste, commercial waste, and residual waste, it's, like you see, it's starting to be a big mess. So instead of having one bin for graphic papers, one bin for brown corrugated paper, we started to have 12, 13, 14 different bins of rejects in paper recycling. So we're making things worse. Good for us. Okay, so how are the sorting technologies done? Currently, the sorting technologies are basically based on the European standard 643. And you have dynamic and automatized systems. You have here the PTS bale mat. So it's a big machine which puts different kind of sensors like near moisture sensors, fiber, plastics, and ash measurements. And you also have the French developing the CTP TechPap, which also measures the moisture and contaminant ratio. But these machines, which are used in recycling waste streams and paper mills, are basically adjusted to to the classic papers, the graphic printing materials, and not so much on the composite packaging materials. And what's happening, you can see a graph with a lot of dots, the variation of the allowed materials in a separate paper waste stream. So basically, the systems are not ready to mix new kind of composite materials in the old inspection systems. There are several sensor technologies in these mixed waste systems where you can use MIR, ultrasonic, lignin sensor, stiffness sensor, gloss sensor, color sensor, and so on. And for example, you can quickly differentiate between brown cardboard, white paper, or gray cardboard. But that was working for the last time. What's the problem? The new bio-based coatings. The latest development in the bio-based coatings is to use lignin. Lignin is basically one of the three pillars of the wood. You have lignin, hemicellulose, cellulose, and everybody is doing lignin coatings. And here is how the lignin coatings looks like when it's printed. We tested for one Finnish company. And basically, you have contact sensors which are measuring the lignin with fluorescent, which was very typical for a bad quality newspaper. And you're using lignin for water vapor barrier properties, and what you're doing, you're scrambling the sensor. He thinks this is a bad quality paper. And basically this is a fresh fiber packaging coated with lignin. We are separating the wood and we are putting it back and we are destroying the sensors. Are we insane or not? I don't know sometimes. So this plethora, as I said, of the lignin coatings, because we are involved in several projects, will be rendered useless, all the systems. They will have to change the sensors, and they will have to change the things, and I appeal every time that when you develop something, you have to think about the end of life of the system. What can help? For example, you can use NIR plus RGB camera plus metal detector plus AI or machine learning systems, and basically you can have some sort of combination of several sensors that you separate something which was previously done by one sensor. I am again a little bit baffled if this is the way. I think the Mandalorian are saying that this is the way. Okay, who watched the series? Other ideas that the Forever Green Alliance, which we are part of, is doing, that it says that we have to have 2 paper bins at home. That would be the solution. One paper bin will be for household collected paper and board, where you can put newspapers and magazines. The young ones are just looking at their phones, and excluding liquid packaging board and certain fiber-based composite materials, which will go into another bin at your home, and then it will go to a special mill which can process this kind of composite materials. So basically, it's back to home problem that we have to sort our problems. So, how we test recyclability? We are doing a lot of recyclability testing for the last 2 years. Previously, it was composting and biodegradation. I always say paper is made for recycling, not for composting, not for biodegradation, because I will ask you one more question. How many times can we recycle a paper fiber? Who knows the answer? Everybody knows, or everybody's scared? 7 is the myth, it's not 7, much more. Technically, if you're using laboratory toys with a closed loop system, 25 times. But one more question, and I will start asking you questions. What is the real usage of a paper fiber? How do you think it really recirculates the system? 3.6 in Europe and 2.4 in the rest of the world. So we have the theoretical 7 to 25, but 25 is the newest data, but in reality it's no more than 2-3 times. Why? Because in the big paper machines, part of the fibers is washed away, or it got contaminated, or it get downgraded, or it have some chemical contamination. So basically, we are killing off fibers too early. With this system. There are several methods to test the recyclability. There is the Italian system, the old eco pepper root method, and there is a very new development which we also involve in Europe. I have to say there is a lot of movement in the paper recycling arena. That's why, because the paper industry sees opportunity that paper is recyclable, and this is the new mantra. Plastic will go to reusing, refilling. This you cannot do with paper, but if you can achieve very high levels of recycling, then we are still will be the good guys, no? And there is one recyclability evaluation protocol, which is already done for standard mills, and 2 more are coming until the end of the year. So a lot of harmonization, a lot of changing things, how to test this. So how we test the product? We do the repulping of the material, cleaning, we do fine and coarse screening, we do paper, and then we do the evaluation of coarse reject, fine reject, basically yield, how much fiber you get back. And we check the visual impurities and sheet adhesion, and then you have a scoring system. And how does it look in the real world? This is a paper-based product with metal foil on it. So this is the coarse screen, this is the fine screen, and these are the leftovers. Is this recyclable? What do you think? It's passed or failed? You're very quiet, audience. It's failed. It's failed. Why? Because all these metallic components would fly around the paper machine and make a mess. So this is a real product, real testing. And another thing, look at these biocomposite materials for lightboard packaging. These are the leftovers from paper-based packaging. Basically, paper-based packaging is something that you have 51% of fibers. And what about the rest of the plastics? That is nobody checking, and this is opportunity to join plastic recycling tests in the overall evaluation. Why? We just check the fibers, and if it goes through the system, we say, yes, the packaging is recyclable. But what about the leftovers? Nobody's checking it. So we basically, I suggest that we make some kind of movement that we join plastic recycling of these residues, and they said this packaging incomplete is recyclable and not just the fiber-based part that is recyclable, because lot of plastic acts as a residue in this system. So, as I said, there is 3 methods, basically the Italian method, the SEPI method, and the German method, but more or less until the end of the year, this SEPI method will be the dominant one. I think just the Italians haven't accepted it yet, but more or less everybody will use this. There are very small differences which are used to test, but sometimes you can get 2 results. In one test it is recyclable, in another one it's not. So some more adjustment is needed, but SEPI method, this version 2, will be the dominating one. As I said, the Lightweight Board Packaging Association also made a recyclability testing protocol. So as I said, lot of movement in the paper recycling business, because, for example, if we take Tetra Pak or different kind of materials, 75% of the weight is craft quality fibers, and 25% is polyethylene and aluminum. But to recycle this, you need a special mill. You need a special equipment, and not every country has this kind of mill. So yes, somebody can write it is recyclable, but maybe it's recyclable 1,000 kilometers away in Europe and not locally. And that's why they also started to make the recyclability testing. So they made the beverage cartons designed for recyclability guidelines, and together with this fiber-based packaging recyclability evaluation protocol, there will be a big harmonization in the recycling of the packaging and paper materials. And basically, by the end of the year, more or less, everybody can check in unison what's happening with the packaging. Is it recyclable or not? So these small differences will be taken out. Okay, just a few words about the inking. Because we also saw in one good presentation that a large part of the toxins in the paper packaging comes from the printing inks, and basically the inking is the removal of the inks from the fibers by a combination of chemical and mechanical methods. We have the chemical part where we have the pulping with caustic silicate peroxide, fatty acid soaps or surfactants, and then we wash it, and then we do some mechanical flotation with added chemicals. And then we can test if we can detach the printing ink from the paper and save the paper fibers back, because as I said, the largest part of CO2 in a graphical printed product or a paper packaging is for paper. So we're aiming for the fibers. This is the inking paper mill, which has all the steps how it's done. But what I want to always point out, especially for the marketing departments, do you know where all the nice colors on your packaging go? Here. In the pile of paper mill sludge. This is a toxic mixture of fiber leftovers, of printing inks, adhesives, anything else, and this cannot be recycled. There are some solutions for upcycling to construction elements and composting, but mostly it goes to incineration and landfilling. So more printing inks you put on, more of this you are producing. Tell that to the guys in the marketing department, and they said, we have to grab the attention of the customer, no? Okay. What's the problem also here? Paper industry is like a dinosaur. It moves very slowly. And basically these methods have evolved in a long, long time. And the shift towards digital printing technologies caused some problems, because all the current methods for detaching the ink from paper are developed for gravel printing and offset printing, which is more or less in a downfall. And there were some ISO standards developed 3 years ago for the inkability testing. We also tested, so basically we test how can we recover a paper, and this is, for example, for inkjet printing. You know why this didn't go away, the color? Any ideas? Because these are water-based inks. And water-based inks resettle on the fibers, and they say water-based inks are better and greener for printing technologies. So it's not everything so simple, no? When you know something like this. This is a good inkable product. This has oily inks, and where you can separate it with the hydrophilicity, hydrophobicity mechanism. So, what are some solutions? I will be finishing quickly. Is to use biodinking. So biodinking is basically using enzymes. It has a steady grow, but the problem is very, very, very specific, or as you say in a love relationship, it's complicated. You're using different inhibitors, pH, temperature, concentration of substrate, and basically you can use for other things in the paper mills, like treatment for the pitch, treatment for the stickies in the paper recycling, removal of fines, and so on. But basically, they're using different kind of enzymes in the pulp paper, which are eating up starch, cellulose fibers, proteins, hemicellulose, glycerol, esters, or pectins. But what cannot you see? Lignin. Okay, if you lignin coat it, this will not work with enzymatic dinking, because the enzymes are not managed to deal with, for example, lignin coatings. So some alternative pathways how to do this. For example, there was a work to use plasma or Corora basically, you stretch the polymeric change of the printing ink, and then you can separate it more easily during flotation. You can see here, but I think it will fail on the test of economic viability of the energy cost. And also there are works of using ozonation, cavity jet inking regarding the mechanical process, and also some kind of bioprocessing of inks that you, from the wastewater you get from the inking, start to produce bioethanol. And there are some works done recently, and the yields are around 20 to 40 that you can get butanol or ethanol from the wastewater after the inking. So you get the fibers, you get some butanol ethanol, but the rest is going for paper mill sludge. But that is a part for the printing ink producers, what to do with the rest of the paper milling stuff. Okay, so to close up, what are the future challenges for this bioinking? Is basically, as enzymes are very, very specific and depend on the use, the mixed weight sources, as I pointed out, will also make a mess here. They are aligned to a clean, sorted waste stream. So when you start to mix different kind of packaging, different kind of coatings, the enzymes will not work, just like some sensors. Then we have also some problems that the paper industry is also facing not just the energy pressure, it's also facing the bioeconomy. That wood is used for biochemicals. And basically you cannot get enough fibers because people want lignin, people want hemicellulose, they want different kind of chemicals, and you're competing on the same market for the same product, and that is a problem. There are some systems that you can use, I don't know, bacterial nanocellulose, that you grow cellulose, which is more pure and has a higher yield than a biomass-based cellulose. But again, we are working with some companies, mainly startups, but they are more in the scale-up system. No, to conclude, as I said, the main challenges is the sustainable raw material supply with quality recycled streams, and here the household multi-streams. So basically our trash bins are the problems for paper recycling targets. The policy industrial alignment across EU regarding recycling strategies, as I said, you check just the plastic, or you check just the fiber, or you check the whole packaging, because it's not aligned. Then we have a combination of green technologies and artificial intelligence, and as I said in several talks, that researchers, students, and companies need to design the new materials based on the recyclability, on the end of life. Nobody will change the end of life channels because of your coating. So it's you always start from the back. Everybody likes a good dinner. Nobody likes to wash the dishes afterwards. But if you will not wash the dishes, you will not have a good meal because your plates will be dirty, no? So basically, always have in mind that you start from the existing end-of-life solutions and then go back to the barrier properties and everything else. And of course, like Justin and everybody else said, reduce overconsumption, because there will be not enough cellulose if we continue to push everything into cellulose packaging. Okay, thank you. Everybody's shy again.
Thanks, that was really insightful, actually, to all the details I didn't know about before with the challenges you're facing. I have a question about, you mentioned these multi-material packaging, so Tetra Paks, things that are paper meshed with metal and plastic. What do you see as a realistic future use of these? I mean, are we going to be able to expand plants across Europe that can successfully handle Tetra Paks? Is that something feasible, or do we instead need to move towards simpler paper materials that don't have so much complexities that have to be treated?
Okay, thank you for your question. We already have I think Italians have a solution. There is a paper mill in Lucca, but you have in Slovenia, it's converted to paper towels and toilet paper. So basically, you cannot achieve, again, the high-quality beverage carton fiber structure, but you get the low-quality sanitary toilet paper. You're basically destroying the best craft fibers to a very low-grade product. So that is not the best solution.
I have one. There is this trend on using nanocellulose to improve paper making properties. Do you know if and how this may also have an impact on the recyclability?
Yes, we have tested a lot of solutions. So basically, you can also recycle lignin. I was a little bit maybe harsh on the lignin, but you have two additional problems. You have a more brownish paper. So if you want the white paper, you have to bleach it. The second is your wastewater is brownish. No? But regarding nanocellulose, if you don't combine it with some polymers which are not very good water soluble, more or less they are all recyclable. The nanocellulose, we have tested the microfiber related, the NCC, and also the bacterial nanocellulose, and all were recyclable. So there are no problems with those. More the combination of the lignin and nanocellulose combinations, because basically lignin is a glue. And it's very hard to dissolve it in water. Okay. Okay, thank you.